All right, so we're continuing to talk about similar triangles. This lesson specifically is about right triangle similarity. Now, I'm going to do a little demonstration, which is sort of what's shown in the first box. Obviously, on the video, you won't be able to see my demonstration. Anyway, so based on that little demonstration there, it's sort of a visual of what this box says. You have this original triangle, which is a right triangle. If you drop down in altitude, you've created 3 triangles that are all similar right triangles. You've got this one on the left, you've got this one on the right, and then you've got the entire original. Those 3 triangles are similar to each other. Because of that, there are lots of proportions that we could write based on this relationship. There's also, therefore, many different values that might be missing in the triangle like this that we could solve for using the proportions, right? So this is really used to solve for missing parts of a triangle. Okay, now there are 2 ways to really think about this problem. And the first way is thinking about the 3 separate similar triangles. So when you have a diagram like this, right, you could think about redrawing the 3 triangles separately and sort of facing them in the same direction so you could clearly see what part goes with what. Maybe I should say there's 3 different ways of thinking about this. The other way to think about it is to kind of name the sides in your head. For example, in the big triangle, there's a shorter leg, a longer leg, and then the hypotenuse, right? And then in the smaller triangle, you could say the same thing. There's a shorter leg, a longer leg, and then the hypotenuse, right? And then in the third triangle, you could kind of see the same thing. Shorter leg, longer leg, hypotenuse. So if you kind of say that in your head, then you know which side corresponds with what. Short side goes with short side. Long side goes with long side. Hypotenuse goes with hypotenuse, etc. Okay. If you take the approach of redrawing, then you have to take into account what angle they share, right? So, for example, we take this original biggest triangle, and the y is the right angle, right? We're going to draw this next triangle, and we can see the medium triangle, W is the right angle. So kind of put a W there. Now, the biggest triangle, the original, and this green triangle, the medium, share one angle. Which angle do they share? They're overlapping each other, and they share, by reflexive property, one angle. Which angle does, I'm just going to call them small, medium, and large, right? Large is the original. Which angle does medium and large share? Thanks. Z. By reflexive property, Z is one of the angles of the medium green triangle there, and Z is one of the angles of the largest XYZ triangle there. Okay, so when we label these 2 triangles, the small and the medium, we know they share angle Z, so we can label that corner Z there. Then we just have the remaining angle. In the largest triangle, the red one, the remaining angle was X. In the medium triangle, the remaining angle would be Y. Then we get to the smallest one, and now we're trying to label that. Now, I know this is already drawn and labeled for you, and I'm just going over how they would label it. But let's make the smallest one blue now, right? Well, if you look at the blue triangle, where's the right angle? Which letter? W. So that's why you would be able to put a W there. Then look at what angle is shared with the original. By reflexive property, this smallest blue angle shares what angle with the original biggest triangle? X, right? They both have X as one of their angles. So see how we put the X up here for the original? Then we know the X goes up there for the smallest. And then the remaining angle is Y. So by reconstructing the triangles, small, medium, large, you can position them in the same direction and see what corresponds with what. So X, Y in this one would correspond with YW. You see that? Yes? Okay. Let's look at it the other way. XY is right here, right? Well, that's the short leg. And then we have to go to short leg of the medium. What's the short leg of the medium triangle? YW. Should I do that again? If you think about the three triangles as having three sides, short leg, long leg, those are the two that come together at the right angle, right? Short leg, long leg, and hypotenuse. The short leg of the original triangle corresponds with the short leg of the medium triangle. What's the short leg of the medium triangle called? YW, you see it? What's the short leg of the smallest triangle? XW. So see, XY, YW, XW. They all end up in the same position when we redrew them because they are all the short legs. They are all corresponding with each other. If we go ahead and talk about long leg of the original goes with long leg of medium. What's the long leg of the medium? ZW. What's the long leg of the smallest? Okay, so even if you don't, so this is what I'm saying, there's three different ways of approaching these problems. One option would be to redraw all three triangles so you can see what's similar to what corresponds with what. Another approach is not to draw them, but just to be able to look at this triangle and think in your head, small leg goes with small leg, goes with small leg. Medium leg goes with medium leg, goes with medium leg. Hypotenuse goes with hypotenuse, goes with hypotenuse. So it's doable without redrawing them, but it depends on which, strategy you like the best. When we have a missing side, so this is asking what similarity statement can you write relating the three triangles in the diagram. Okay, so let me start with the largest triangle, and I'm going to call it QRP. So now we would have to be careful of our order and name the medium triangle. Well, QRP, I ended with the, actually I'm going to rewrite that. I always like starting with my right angle. Sorry, I forgot to look carefully. I like to start with my right angle. It just really gives me a definite place to start. Right angle. So I'm going to start with P. Let's go PQR. So now when I go to my medium triangle, go straight to the right angle and start there. What's the letter that goes with that right angle? S. Now, we got to figure out which direction we are going. My original, I did P to Q first. So was that along the short leg or the long leg? P to Q, does that look like the shorter leg or the longer leg of the biggest triangle? Of the biggest triangle. That's the shorter one of the biggest triangle. So now we have to go from S to the short, along the short leg of the medium triangle. So what letter should come next? P. And then R, because that's all that's left. Now we'll go to the smallest triangle. Again, go straight to the right angle. What letter do we start at? S. Now we have to go along the short leg first, so what comes next? Q and then P. Okay. Number 2, now we've got X's and Y's. We're not writing a similarity statement. We're literally setting up a proportion here to be able to solve. So if I want to solve for X, does that look like the shorter leg or the longer leg of the right triangle? It's a little bit iffy, right? But it's the shorter leg. And we can tell because this number is smaller. This is going to be shorter. On this whole side is like the smaller side. Okay, so X is the short side. In the biggest triangle, X is the shortest side. Now, in the biggest triangle, do we have another side? Do we have the long leg or do we have the hypotenuse? We have the hypotenuse, right? So this is short to hypotenuse. Well, what's the length of the hypotenuse? Now, we want to be able to not involve y right now, right? Because if we involve y, then we have to involve a system of equations. We need to try to involve just x's so that we can just solve for x. So the largest triangle is the one we just did. Medium triangle is here. Is there an x on the medium triangle? No. So let's go to the smallest triangle, which is this one. On the smallest triangle, what would be the ratio of short to hypotenuse? Because that's what we have set up here, short to hypotenuse. Erica? You guys see that? Short to hypotenuse on the biggest triangle is on the left. Short to hypotenuse of the smallest triangle is on the right. Now we cross multiply. X times x is 4 times 9 is, how do we solve this? Square root both sides. Square root of x squared is 6 or negative 6, but we can eliminate negative 6, right? The length of a side can't be negative, but technically the square root of 36 is 6 or negative 6, right? But so 6 is going to be our answer for x. Now let's do the same thing for y. The y occurs right on this segment here. Is that one of the sides of the smallest triangle? Is it one of the sides of the medium triangle? Is it one of the sides of the largest triangle? No. So we're not going to involve the largest triangle when we're solving for y. We're going to involve the smallest and the medium. So let's start with the smallest side. The smallest triangle. We know x now is 6, so we could use that, but we probably don't even need to. We can just use what they gave us, the 4 and the 5. Okay, so let's do y is to 4 on the smallest triangle. Well, in words, what would that be? Long leg to short leg, right? Long to short. Okay, so on the medium triangle then, let's write a ratio of long to short. What's that going to be? 5 to y. Cross multiply, you get y squared equals 20. Y equals the square root of 20. Pretty soon I'm going to teach you how to simplify that, but not till after this test. On your calculator, you could get a decimal. But at this point, I'm going to leave it as the square root of 20. Okay? Did you notice anything that happened with both of those? Yeah, you had to square root. There was a y squared. There was an x squared. That's going to happen every single time. Yeah. The top of one of your ratios will be the same value as the bottom of your other ratio every time. It might not always be the variable, but the top of one ratio will equal the bottom of the other ratio every time. Like I said, it might not always be the variable, but you will always have this situation. So let's look and see if we can do this one a little bit faster, okay? X over, let's do the y first. I'm going to do y to 50 in my biggest triangle. That's short leg to hypotenuse. You see that? Short leg to hypotenuse. Okay. Well, now if I do short leg to hypotenuse of my smallest triangle, what's the hypotenuse of my smallest triangle? Which one? Y. And what's the short leg? 10. So you see how it ends up again? Y on top, y on the bottom. And then you have to, right, cross multiply and end up taking a square root. Okay. We could keep going with that. This is a little FYI. There's something called the geometric mean. You guys know how to find the mean of 2 numbers or 3 numbers or 10 numbers or whatever, right? Add them up, divide by the number of numbers, right? That's the average. Another word for average is mean. So that is that's the mean that you're used to. This is a different kind of mean. It's called the geometric mean. And the geometric mean can be found of 2 numbers. Now, if you Google this, you're going to get a really big, long, complicated formula, an explanation, but to simplify it, the geometric mean of 10 and 15 can be solved using this proportion. The geometric mean being the x. X on the top, x on the bottom. If you're finding the geometric mean between 2 numbers, those 2 numbers go in the other 2 spots. You cross multiply, you solve, and that's the geometric mean. So the fact that this happens naturally with our similar right triangles here is related to the geometric mean. So on that note, I'm going to teach you my third way. Remember I said there was 3 ways to think about this? I'm going to teach you my little trick. Now, the problem with tricks is if you forget how to do the trick and you don't understand the geometry of it, you don't have any way of coming up with the trick. Which is why I wanted to teach you the similarity of it first. You can always revert back, if you understand what we're doing, to that. But this is a little trick, and you should just watch for now. Okay? You don't have to write it down, just watch. Whenever you have one of these types of problems, with the altitude drawn down like this, if you turn your paper so that it's the original biggest triangle's right angle is at the top. Now think of this as like the bottom and the top. Okay? When you drop that altitude down, you split this hypotenuse into 2 smaller parts. So now we really have 3 parts three segments that we can talk about in that hypotenuse. This segment, and then the whole thing, right? So you could have the whole hypotenuse, the longer section, or the shorter section. There's three segments you can talk about there, okay? My trick is keeping in mind that this is the geometric mean of two of those parts. This one is the geometric mean of two of those parts. And this one is the geometric mean of two of those parts. So again, if you turn your paper so that the right triangle's at the top, the original right triangle, I mean, right? And then think of these as the three segments that are kind of shooting down from that right triangle. They shoot down and they connect with that opposite side. Okay, when this one shoots down, this one that I called X, shoots down, it hits this point right here. That's an end point. What two segments of that bottom also shares that as an endpoint? The shortest one and the longest one. So X is the geometric mean of those two. Keep going. Y shoots down, connects with the opposite side at this endpoint. What two segments share that as an endpoint? The smallest one and the medium one. So Y is the geometric mean of those two. Z comes shooting down, hits that opposite side at this endpoint. What two segments share that as an endpoint? Medium and whole. So Z is the geometric mean of those two. So if we actually try to solve these, let's look at number 18. I'll let you go back to the other stuff in a second. We're trying to solve for X and Y here. Like I said, you can redraw these three triangles as similar triangles. You can think about the long to the hypotenuse and short to hypotenuse, whatever. Or you can think about the geometric mean trick that I just taught you. Y comes shooting down, hits right here, and is the geometric mean of two of the sides. So if I know if it's the geometric mean, then I'd put Y up and Y down. One up, one down with my Y. Now, which two numbers is it the geometric mean of? It connects here. That's the endpoint of 3 segment and 9 segment. So 3 and 9. And then you solve. If we want to solve for X, X comes shooting down from the top, therefore that's the geometric mean of two numbers. Which two numbers? So it hits right here. It's the endpoint of this segment, which is 9. And what other segment? The whole thing, not 3. 12. Right? Because this endpoint, where X comes down to, does that touch just the 3 segment? No, it touches the 9, and it touches the whole thing. So we have to think of the whole thing as being 12. So then we would solve that. Does that make sense? Maybe that's the wrong question. Do you understand? Okay. I'm going to pause this and let us practice a little bit.